So we were talking about just hold on 1 second. Let me put the charger on. I said this one. So we were talking about the order of reaction, right? Uh, and I had explained to you order zero means that the rate of the reaction does not depend on the concentration of the reactant. Order one means that the rate of reaction is directly proportional to the concentration of the reactant. And order two is that the rate is too much dependent on the concentration of the reactant. That you double it, it becomes four times. You reduce it by 50%, the rate of or the speed of the reaction decreases by one fourth. So we had three orders, and I had explained to you why the so this is what we were talking about. I had explained to you that why does rate not get affected by the concentration of certain reactants, especially the zero order one, when we have already studied that whenever you increase concentration, the rate of the reaction speeds up. And the answer to that was that reactions don't happen in one step. Most reactions are multi-step reactions. And when they are multi-step reactions, uh, then the rate of the reaction is only dependent on the slow step. So for example, this reaction over here, it's got two steps. The halogenoalkane first breaks down and heterolytically breaks down, forms a carbocation, and then the carbocation gets formed. Then the OH, the other reactant, comes in and bonds with the carbon and forms the alcohol. So the second step was your fast step, and the first step was the slow step. So the speed of the reaction is only dependent on the slow step. Any reactant that's in the slow step has order one. If I increase the concentration of the halogenoalkane, this 100-second step would speed up, and it will, let's say it becomes 50 seconds. So that indicates that the reaction is speeding up a lot. If I speed up, if I increase the concentration of OH ions, then that indicates that the reaction will speed up, but the fast step will speed up. And the fast step will have negligible effect on the overall time of the reaction. Okay? Is this part clear that
I have a question.
yes?
In the slow step, is the order always one, or could it be two or anything?
That one. So where does order two come from? First thing, it's it's order one. I'm going to talk about order two now. So there are two ways that it could be order two. So let's discuss how the order could be two. Now let's do another mechanism. Now this other mechanism is that there's a reaction which is NO, and that NO is reacting with a Br2 molecule, and it's forming two NOBr. So we've got this reaction going on. Now the mechanism, let's say this reaction is divided into two steps. There's a step one. Step one is that NO comes in, one NO, reacts with one of the Br2 molecules and forms one NOBr. And there's a Br radical that gets produced. Step two is that this Br goes and then it reacts with the second NO and forms another NOBr. So that's the mechanism of the reaction.
The individual Br is a Br radical?
Yeah, it's a Br
Okay.
atom. ठीक है. I mean, I just made this mechanism up. ठीक है. I don't know if this is what the mechanism is. So I just made this up, that this reaction is happening in two steps. The NO reacts with a Br2 molecule, takes away one Br, bonds with it, NOBr is formed, and a Br atom is left. That's a radical. And then that Br comes in and reacts with the other NO and forms another NOBr. So that's how your two NOBr molecules get produced. So this is how the reaction is proceeding. Now, let's assume that the second step is my slow step and the first step is my fast step. So the rate of the reaction will depend on what? It will depend on the slow step. You speed up the slow step, the rate of the reaction speeds up. So your rate of reaction will be dependent on the concentration of these two things, right? So my rate of reaction depends on the concentration of NO and it depends on the concentration of the Br radicals. Is this clear? ठीक है? Is this clear to everyone?
Yes, sir.
Yes, sir.
ठीक है. So your rate of reaction depends on the concert. Like if you increase the concentration of any of these two things, your slow step would speed up and your rate of reaction will speed up. So your rate depends on these two things. Now what happens over here is, remember this Br radical is not your reactant. It's an intermediate. So that's an intermediate, and what that means is that when I say that the rate depends on the concentration of Br, right? The Br itself depends on other things. I mean, look at Br. When will the concentration of Br be high? You're going to have a higher concentration of Br if you have a higher concentration of NO and Br2. Is that clear? So the concentration of Br radicals, it indirectly depends on Br2 and NO. Do you get my point?
Yes, sir.
So when I say that my rate of reaction depends on Br's concentration, right? Br itself depends on other stuff. It depends on the concentration of Br2 and NO. You increase the concentration of NO and Br2, then the Br concentration will increase, right? So that means if I say that the rate depends on Br, right, it actually indirectly depends on these two things. So I'm going to replace Br and I'm going to substitute Br with what it depends on. It depends on NO concentration and it depends on Br2 concentration. So is this clear? This part?
Yes, sir.
Okay. So remember, I'm just going to repeat everything. Rate of reaction depends on the slow step. It depends on NO concentration and Br concentration. But Br itself was an intermediate that was produced in the previous step. So when I say rate depends on Br's concentration, so Br itself depends on these two things. It depends on the concentration of these two things. So I'm going to replace Br with NO and Br2. Okay. Is this clear, everyone? Minahil, Amna,
Yes, sir. Yes, sir.
Akshita, is this? So now if I collect all the terms, NO is coming twice. So that means NO is power 2 and Br2 is coming once. So Br is order 1. So this one, the first one is order 2 and the second one is order 1. So that's how you get second order. Is that clear?
Yes, sir. Yes, sir.
So I'm also going to explain to you why your rate of reaction would be very sensitive to NO's concentration. So have a look. So let me get rid of all of this. So I'm going to explain now. So it's order 2, right? Now, if I increase the concentration of Br2, right? So Br2 concentration increases, right? Br2 is order 1. So if I increase the concentration of Br2, because of Br2, whose concentration would increase? Br's concentration would increase, right? More Br is going to get produced. So in my slow step, only one of the reactant gets affected. the Br concentration increases. The NO concentration does not get affected. So Br2 is order 1. That the rate of the reaction is speeded up. Br2 concentration increases. Br's concentration gets increased. And in my slow step, one of the reactant, its concentration increases. Now see what happens if I increase NO's concentration. So if I increase NO's concentration, now NO is already in the slow step. So NO concentration increases, the rate of the reaction speeds up. Slow step would speed up. But if I increase NO's concentration, NO is also involved in the first step. Br's concentration increases. So because of NO, the Br, the other reactant in the slow step, its concentration is also increasing. So not only will the slow step speed up once because of NO's concentration, but it will speed up again because the Br concentration is also speeding. It's also increasing. Do you get the point why it's squared, right? Is that clear?
नहीं sir, can you explain it again? The square word again.
देखो Br2 है ना, that's order 1, right? That means the rate of the reaction is directly proportional to Br2. And remember
सही है sir.
the whole reaction depends on the slow step. If I increase Br2's concentration, so whose concentration will increase? Br, right?
Yes.
So in my slow step, what effect will that happen on the what effect will that have on the slow step? In your slow
Fast
step,
होगा.
it will speed up, right? Because Br's concentration is increasing, right?
Yes.
लेकिन only one, not NO's, ठीक है? Only Br's concentration. अच्छा,
सही है sir.
now I'm going to repeat the whole thing. ठीक है? Now I'm going to increase NO's concentration. Now, if I increase NO's concentration, so what happens to the slow step? The slow step speeds up, right? Because I'm increasing NO's concentration, right? Is that clear?
Yes.
I said, again, because of NO's concentration, because NO is also in the fast step as well, Br concentration also increases, right? So in my slow step, if I increase the NO concentration, both reactants, their concentration gets increased. Is that clear?
Okay, सही है sir.
So इसलिए that's order 2. That means the rate of the reaction is more sensitive to NO's concentration because if you increase NO's concentration, not only does NO speed up the reaction in the slow step, but because of NO, Br also increases. So Br also speeds up the so that's double the effect. Is that clear? So square represents that the reaction, like if you double the concentration of NO, reaction speeds up. But doubling the concentration of NO will also double the concentration of Br as well. So the reaction will speed up once more. So the rate will increase 4 times. Is that clear?
Yes.
ठीक है? Is this clear to everyone?
Yes, sir.
ठीक है? So what you need to note down is you need to find out what the intermediates depend on. Okay, so there's a let me find one question in the past paper where they had a very similar question. Wait a second, read. I think it was kind of an older question. Just give me 1 second. No, not this. Yeah, this one. See, yeah, let's try and do this question. That's a very similar question. He's given you 3 options. He said that, so this is your overall reaction, right? That's your overall reaction. So rate would depend on these 3 reactants. And so he's given you the rate equation. The rate depends on these 3, but you don't know what ABC, what the orders are. So you're not sure what ABC are. Now he's given you 3 options. What if step 1 is the slowest overall? So there are three steps. So there are three cases that he's giving you. What if step one is the slowest? What if step two is the slowest? And what if step three is the slowest? So let's assume what the order would be if step one is the slowest. So what would rate depend on? Rate would depend on these two things, right? Is that clear?
Yes.
So that would mean that rate would depend on H2O2, that's going to be order one. And rate would depend on I minus one, that will be order one as well. And it will not be dependent on H plus one, so that's going to be order zero. So ABC, you have the values for ABC. Is that clear?
Okay, सही है sir.
As the same question. What if step two is the slowest? So if step two is your slow step, so rate depends on these two things. The rate of the reaction would depend on IO minus one, right? And depends on H plus one.
So if like one of the reaction is slow, then like the other two we're gonna consider as fast.
Yeah,
Okay.
ठीक है. And that's what they normally mean. ठीक है, so you're going to have one slow step. That's the one on which the rate of the reaction depends on. Now this one, what if step two is the slowest? So rate depends on the concentration of H plus one. It depends on the concentration of IO minus one. But see, IO minus one is an intermediate that was produced in the previous step. So when I say rate depends on IO minus one, it indirectly depends on I minus one and H2O2. Is that clear?
Yes.
So when I say rate depends on IO minus one, IO minus one itself is produced by H2O2 and the other one, which is I minus one. You already had H plus one, so I'm going to just copy that. So this is what I'm going to get. So it's going to be order one with respect to all of them. A, B, and C values would all be order one. Is that clear?
Yes, सही है sir.
Isn't H plus order 2 though?
Why is it order two?
Because it produces HOI and H plus in the next reaction for the fast one
No,
below
that
it.
no, the rate of the reaction depends on H plus one and IO minus one, right? So it's only dependent on these two things. That's it.
No, but like you said that like the other two reactions are the fast ones. So the step two, the H plus, if it doubles or like if it increases, it affects the concentration. It increases the concentration of HOI, which is in the second reaction,
No,
and the H plus in the
but
third
this
one. Sorry.
no, but this one, this reaction over here, that is the fast step. Like if you're assuming that second one is the slow step, right? That's the fast step. That does not affect the rate of the reaction. No
Oh
matter
yeah.
no matter what the concentration of these things are, the rate of the reaction is not going to speed up. Is that clear?
Okay.
Like
Yes.
if it's already zero point 0.1 seconds, right, and this one is the slow step and it's taking 50 seconds, we don't care about the zero point 0.1 second reaction, right? The rate will, like, whether this speeds up or not, the overall speed barely changes. Is that clear?
Yeah. And the previous example you gave, you increased the concentration of NO in the fast reaction, and that affected the slow reaction, right?
No, that was I was just showing why it was order two, right?
Okay.
So what you're going to do is I'm going to do that again once more at the end. What you're going to do is you're just going to keep things simple. The rate only depends on the slow step. So that means rate only depends on IO minus one and H plus one. That's it, right? And I'm just going to replace IO minus one because IO minus one was produced in the previous step because of I minus one and H2O2. So when I say rate depends on IO minus one, it actually indirectly depends on H2. So I replace IO minus one with H2O2 and IO minus one. And that's it. That's my rate equation.
So why can't you just do IO minus one though?
No, because
Even
that's
though it does,
that's
huh?
no, that's not an intermediate because your original reactants are H2O2,
Oh,
I
okay.
minus one, and H plus one, right?
Got
So
it.
so you're not even adding that. That got produced somewhere in the middle of the reaction, right? Okay, so let's now do the other one, which is let's assume that step three is the slowest, right? So if step 3 is the slow step, right? Then your rate of reaction depends on these three things. So your rate of reaction depends on HY, and it depends on H plus 1, and it depends on I minus 1, right? Now, the same problem that this HY is an intermediate that got produced in the previous step. So when I say rate depends on HY, that actually means that rate depends on H plus 1 and IO minus 1. Is that clear?
And you would say IO minus 1 is H2O2 plus I minus.
Yeah, so again, now we've got another problem that is that IO minus 1, when I say rate depends on IO minus 1 itself is an intermediate that was produced because of I minus 1 and H2O2. So I'm going to get rid of IO minus 1 and I'm going to replace it with I minus 1 and H2O2, right? So if I collect all the terms now, the H2O2 is appearing once and the H plus 1 is appearing twice. So that's going to become H plus 1 squared. And your I minus 1 is also appearing twice. So that's I minus 1 squared. So two of them are order 2, one of them is order 1. Is this clear?
Yes, sir.
Okay, so that's how we figure this out. And
सर ऑर्डर जीरो कैसे आएगा अगर आना
what
चाहिए?
the fast step? Now, if it's in the fast step, it's order 0.
ओके हाँ फिर
Okay. So first one is the first one, if the first one is the slow step, right? So rate depends on
यस
H2O2, I minus 1. It does not depend on H plus 1, so that's order 0, right?
ठीक है सही सही
Achha, so I'm also going to show you how. So this is how you're going to do it, okay? So this one is that if the third one is a slow step, I'm just going to show you why it's going to behave like this. So if I increase the concentration of H2O2, whose concentration gets increased? IO minus 1. Because of IO minus 1, whose concentration gets increased? HOI. So in my slow step, only one of the reactants concentration increases. So the reaction speeds up proportionally, right? So H2O2 is order 1. Now see what happens if I increase the concentration of H plus 1. Focus on the slow step. Well, there's H plus 1 in the slow step. So that means the rate of the reaction in the slow step increases, right? I'm increasing H plus 1 concentration. But since I'm increasing H plus 1 concentration, the HOI concentration would also increase. So that means by increasing H plus 1 concentration, two of my reactants in the slow step, their concentration doubles. So the rate of the reaction increases by a much bigger margin. Is that clear?
यस सर
Okay. Again, just remember how to figure out the order of reaction. Now, one more thing. Okay, there's supposed to be one more thing, and that is the coefficient in the slow step becomes the exponent.
अरे सर ये वही चीज़ है जो हम लोग के लाइक ए एस के
नहीं
अंदर
नहीं
लाइक के पी के फॉर्मूले में लगाते थे कि
नहीं नहीं different है. That's totally different.
अच्छा ओके सही
Acha, so your coefficient in the slow step becomes the exponent. Remember that. Now, normally what happens is they're all going to be 1 moles. When you like the overall equation is going to have more moles, but your steps normally you don't see more than 1 mole. It's one NO. The other NO shows up in some other step. Even if there are two NOs, but they're going to show up in different steps. So normally what happens is when you look at a mechanism of any reaction, there's only one species at a time that's getting involved, right? Is that clear? So the exponent is always, I mean, the coefficient is always 1. But if in the slow step, if ever in a slow step, you see something like this happening, that um, there's a slow step and this happens, that for example in the slow step you have 2NO. ठीक है, forget the overall mechanism. if it has two molecules, like two NO reacting together, and let's say they are forming, what are they going to form? They're going to form two NO2s reacting together, and they're forming N2O4. And let's say this is your slow step. So the rate of the reaction depends on the reactant, right, in the slow step. So your rate of reaction would depend on NO2 concentration. But since there are two of them involved, so it's going to become the exponent. Okay, so keep this in mind as well. Normally in mechanisms, you just have one reactant. But if uh, there are two reactants showing up in the slow step, then you make two the exponent. That just means that rate of reaction depends on one NO2 and it also depends on the other NO2. So that becomes power 2. Is that clear?
Yes.
Okay, normally this will not happen in most cases. Like even in this one, the example that we did, like you had 2I minus 1, 2H plus 1 in the overall reaction, but in each step there was only one reactant that was, or one species that was involved. So normally this does not happen. But if they had written 2I minus 1 over here and this was the slow step, then you would have taken it as order 2. I minus 1 would have been I order 2 by default. Okay, so hopefully is this clear? This whole thing. Is this clear?
Yes.
Yes, sir.
Saro, clear? Is this clear? Zohair, Akshita, Amna,
Yes, sir.
everyone? Okay.
Yes, sir.
Achha, now the third one, okay, that will kind of sum this chapter up. So method number 3. So method number 3 is if you want to find the order of reaction. So method 3 is you just do experiments, right? Uh, like if you want to figure out if something is order 0 or not, right? Like rate is proportional to the concentration of X, and you want to figure out whether it's order 0 or not. What are you going to do? You just do an experiment. You double the concentration of X and see if rate changes. That's it. If the rate does not change, that means it is order 0, right? So method number 3 is the experimental method. Instead of measuring the half-lives, instead of making all those graphs, instead of looking at the mechanism, just do an experiment and you'll figure out what the order is. Now, the only problem with this is that normally what happens is a lot of reactions, they have multiple reactants. So if there's X and Y reacting and they're forming Z, right? So your rate of reaction is not just dependent on one reactant. It is dependent on the other reactant as well. So the question is, if I want to just investigate, because remember, rate will be affected by both reactants, not just by one. So if I want to figure out what is the relationship between rate and X, so what I'm going to do is I'm going to keep Y constant. So keep the concentration of Y constant. Is that clear? And you'll figure out, let's say you double the concentration of X, what happens to the rate? You'll figure out what the relationship is. If the rate does not get affected, that means it's order 0. If it gets affected proportionally, that means it's order 1. If you double X and the rate becomes 4 times, that just means that's order 2, right? So you have to keep the other reactants constant, right? Is that clear?
Yes.
And vice versa. If you want to investigate the relationship between rate and Y, you have to keep X constant then. You have to keep the concentration of X constant. Now either keep it constant or There's one way you can keep the concentration of all reactants constant, and that is to add them in excess. What you can do is add other reactants in excess. That means that you add so much of Y that even if a tiny amount of Y gets used up in the reaction, its concentration barely changes, right? For example, if this is zero point 0.1 moles and this is like 100 moles. So if the concentration of X decreases by, like if X gets completely used up and the reaction is over, right? So the moles of X zero point 0.1, it goes to zero. What will change in the amount of Y? There would barely be any change, right? From 100 moles, it's going to become 99.1 moles, right? So that's barely any difference in the quantity of Y or the concentration of Y. Is that clear as well?
Yes, sir.
So remember this thing. If in any experiment whatsoever, if you want the concentration of a reactant to be constant throughout the reaction, so add the other reactant in excess so that its concentration remains constant throughout the reaction. So you add the other one in excess. Uh, because otherwise you'll be confused whether the rate of the reaction is changing because of Y or is it changing because of X. So keeping Y constant, you would be pretty sure that the rate is being affected by the changes that are happening in X. So now the questions related to this are kind of simple. Like I'm just going to pick questions. Let's start with some easy ones. Yeah, that's let me open the latest ones. Just one second. Do you see a 2020? Yeah, this is 2020. You're starting with this one. So by looking at the experiment, I'm going to try and figure out what the order is. Here's my experiment. Now I know that rate depends on NO and O2, right? So so there are three experiments. This is experiment number one, this is experiment number two, and this is experiment number three. He is changing the concentration of NO and he's changing the concentration of O2 as well, and he's trying to figure out what is the change in the rate of the reaction, the initial rate. So, tell me which experiment should I compare first? Like, if I want to figure out,
I think the last one is the constant one.
yeah, you can compare two and three, right?
Yeah, I think the third one is the one you compare with.
The one and three or two and three? I mean, you can do two
I
and
was
three.
just saying, I was just thinking that the third one, because both the concentrations are the same, I was like, it's probably the constant one which you compare between one or two, right?
Nee, remember, we have to compare between experiments. What I need to do is, this is what we're going to do. I need to figure out, NO, like how would the rate get affected by NO? So I need to compare it in experiments where O2 is kept constant.
So it would be one and three, right?
So it's
If you're
good.
comparing N.
So it's going to be one and three, right?
Yeah.
So I'm going to pick experiment one and compare it with experiment number three. And I'm going to see how the rate of the reaction changes, right? So so O2 is not playing a part because O2 is kept constant. So it's not playing a part. So I'm just investigating. So what's happening to NO over here? So you have to find out the factor. Like it's decreasing by 50%, right? It went from zero point 0.1 to 0.05, right? One way to figure out this factor is that you take this value divided by the previous value. So
It's
you're,
decreasing by 4 times.
and what's happening to the rate of the reaction?
It's decreasing by 4 times, so 1/4.
So what kind of relationship is that? Is that order one, two, or zero?
Order two. Order
Order
two.
two. So that means X over here is 2. Is that clear? And this is what you're going to write. The way you're going to describe this is it's like over here. If you look at the question, he says, how do you figure out the order with respect to NO? So what you're going to write over here is that you compared, you're going to tell them which experiments you're going to compare. So you compare experiment 1 and 3, right? And you're going to tell them what just happened. It's just 2 lines, right? So you're going to state that NO concentration is halved and your rate of the reaction becomes 1/4. So that means, which shows that the order with respect to, which shows order with respect to NO is 2. That's it. That's your statement. Is that clear?
Yes, sir.
Okay, is this clear to everyone? I said now,
Yes, sir.
now similarly, so we didn't find O2 yet. We found NO's order. We didn't find O2. So we're gonna do O2 now. So I'm gonna do the whole thing. Now what I'm going to do is I've already figured out NO. I know that's order 2. I don't know what Y is. So now I'm going to keep NO constant. I need to get rid of NO. So which experiment should I compare?
Two
Two
and
and
three.
Okay, so now it's going to be 2 and 3, right? And so NO is not changing. So NO is not playing any role. What is happening to O2? That's halved, right? And what's happening to the rate of the reaction? You can remember you want to
half.
find halved, and so you take this value, divide
Yes.
this, so it's also halved. So what kind of relationship is that?
One.
1, right? 1 means directly proportional. So that means Y is so this is what you're going to write. You compare. You're going to tell them which experiments you're comparing. Compare experiments 2 and 3, and you're going to tell them that O2 is halved. O2 concentration is halved, and your rate becomes is also halved. So which shows order with respect to O2 is 1. So now I have my whole equation, which is rate is, I'm going to get rid of the proportionality sign. I'm going to put K over there, and I'm going to have NO that's power 2, and I'm going to have O2 that's power or order 1. Is that clear?
Okay, say yes, fine.
Okay, is this clear to everyone?
Yes, sir.
Okay. So, so we figured out the order. The only last thing that you need to do now is how do you find K, the rate constant? You just plug in the experimental values for any one of these. You know the orders now, uh, and you can find K now. Just plug in any values. Like I'm going to plug in the values for experiment number 1, right? So the rate is what, 3.5? I don't know what K is. NO concentration is zero point 0.1, and that's squared. And O2 concentration is given as 0.05, and that's power 1. Can somebody tell me what K is?
So 7,000.
Confirm is 7,000.
No, I can't write.
double check this. It's That's how you're going to find K, right? Achha, but is this clear? The third method of finding the order of reaction, is that clear?
आंसर सही है 7000 ही है सही है
ठीक है. So that's the third method of finding the order of reaction. And but see, that's pretty much it. That's kind of the whole
अरे
chapter.
सर
ठीक
I
है. हाँ.
have a
सर ये
question.
एन
Yeah.
Um,
Yes.
okay, I'll go. Like this K you found in terms of NO, right?
Nee, the K
Like,
we've
yeah.
nee, we found the rate equation, right? K was just a constant because we had a proportionality sign. K is the rate constant, right?
Oh, okay, got it,
So
got
I
it.
just plugged in the value for the experiment. I did an experiment. I took one experiment and I put in all the values over there.
So you could do any of them.
Yeah, you could do any, and it's a constant, right? So it should come out to be the same value for any experiments,
Okay.
right? So this is what they normally do. They At the end of the day, they're going to ask you for the rate constant K. That's pretty much in like in all, like for example, this one they're asking you to figure out the order. They're going to ask you for K as well. So for K over here, he's asking use the results of experiment number one to find out K. So once you have the rate equation, you can just plug in the values for experiment number one and find out what K is. Is that clear?
सही सर
ठीक है. There's just very few minor things that are left. Otherwise, the chapter is kind of over. I'm going to share the worksheet. ठीक है, we'll do the worksheet in the next class. ठीक है. चले. Okay, everyone. Any other
ओके सर
questions
बाय
about this?
नो सर सही हो
Okay, take care.
Thank you, sir.